Good morning, all. In today's session, we will see an introduction to LEX and the implementation of our sample program. So, here the topics covered in this session are the LEX, what is LEX, theory related to the LEX, how we can execute a LEX program. So, what is LEX? Basically, the LEX is a program or the generator that generates the lexical analyzer. It is mostly used with a YARC parser generator. So basically, the LEX is a tool or a computer program that generates the lexical analyzer or converts the stream of characters into the tokens. The LEX tool itself is a compiler. The LEX compiler takes the input and transforms that input into the input patterns. So basically, it is commonly used with the YARC, that is yet another compiler. So with the help of the LEX program, we can write the regular expression. So basically, the regular expressions that are translated by the LEX to a computer program that mimics the finite state automata. So basically, it can be written with the pattern like letter or digit star, that is one or more occurrences of the letter or the digit. So basically, this pattern matches the string of characters that begins with a single letter followed by the zero or the more letters or the digits, which is also shown with a figure, with a finite state automata. So with the states of 0 to 2, we can start at 0. It will contain a one letter. With a one state, it will contain a one letter or the digit, that is 0 or more occurrences of the letter and the digit, and we will reach at the end of the state. So that will be marked with a double circle. So when we will write the LEX program, we have to take into the consideration some meta characters and what is the meaning of that particular meta characters. So if we will write the regular expression with some dot, then the meaning is that any character except the new line, it is accepted. If the regular expression is written with a slash n, the meaning is that it is a new line. If it is written with a star or the asterisk, it means that the 0 or the more copies of the preceding expression. If the regular expression is written with a plus, it means that one or more copies of preceding expression. If the meta character is used as question mark, it means that 0 or 1 copy of the preceding expression. If it is written with a raised to symbol, it is meaning that the beginning of the line. If it is written with a dollar, it means that the end of the line. If it is written with A or B, it means that A or B. If it is written with a round bracket with a plus, so the round bracket that can be used for the grouping, and the group that is nothing but the AB, which will contain the one or more copies of AB. If it is written with a plus, it means that the literal A plus B. If it is written with a square bracket, it means that it is a character. Next, we will see some other pattern matching primitives. That is, if the expression is written with ABC, it means that we are matching with the same expression, that is ABC. If the pattern is written as ABC star, it means that there is AB with 0 or more occurrences of C. That's why here it is written as AB, ABC, ABCC. Likewise, if the expression is written as ABC plus, it means that with AB, there is 1 or more occurrences of C. It means that there must be at least one C is present with an expression AB. That's why the matches are given as ABC, ABCC, ABCCC. If the pattern is written as ABC plus, it means that we are grouping the characters with a round bracket, that is BC, and one or more occurrences of that particular pattern, that is BC. So that's why the result is given as ABC, ABC, BC. If the expression is written as A in round bracket, BC question mark, it means that the 0 or more occurrences of the BC. That's why the matches are given as A, B, C. If the expression is specified in square bracket, like within a square bracket A, B, C, it means that either one is present, the match is found. That is either A or B or C. If the pattern is given within the square bracket with A to Z means any character from A to Z. If the pattern is given like minus AZ, it means that the one of the pattern, that is minus A or Z. If the pattern is given like capital A to Z, small a to Z, or the digit from 0 to 9, it means that a one or more occurrences of that particular character. If you want to specify the white spaces, then that can be specified with a square bracket, that is /t/n. If we are specifying within a round bracket, that is negation with AB, then the characters accepting anything except A and B. If the pattern is given, that is A negation B, it means that any character within this particular 3. If the pattern is given as A or B, it means that the anything, that is either A or B. So these are some of the expression with their matches are given over here. Now, the structure of the LEX is specified with a 3 sections. These are the definition section, the rule section, and the code section, or you can say the auxiliary section also. So with the definition section, we can declare the variables. With the rule section, that is defined with %%, we can specify the rule that consists of the pattern or the action. With the auxiliary section or the code section, which holds the auxiliary functions that can perform the action. So this is the basic structure of the LEX that can be used. With the help of this particular basic structure, within the code section, we can write some function. For example, here the function are given as y/lex. So what is the meaning of this particular y/lex and what are some other functions these are used with a LEX program? So some of the functions that are listed over here are, that is, if the y/lex is used, it means that it will invoke the lexical analyzer, which will return the token. If the function name that can be used as y/text, it means that the pointer to match the string. If the function is used as yyLength or yyLeng, it means that the length of the match string. If the function is used as yyVal, it means that the value that is associated with that particular token. The function, the yyWrap, that can be used, which will return 1 if there is no any error. If it will return to 1, else it will return to 0. The yyOut will specify the output file. The yyIn will specify the input file, which will be specified with the help of the pointer to that particular file. The initial that will state the initial start condition. The begin that will hold the condition, which will switch to the start condition, and the echo, which will be write the match string. So these are some of the predefined variables, or you can say the functions that are used to write the LEX program. So here we have seen the structure for the LEX program and what is the meaning of that particular structure and what are the different predefined variables that are used. With the help of this, we will see one sample program. So here with this particular sample program, we can count the number of the words. So here, the definition section is written. With this particular definition section, we can declare the variables. So here, the variable I is required, that will be initialized to 0. In the rule section, we can write the regular expression. So my words that will contain the characters, which will contain from capital A to Z, small a to Z, the digits from 0 to 9, and any number of the occurrences of the characters. So that's why the regular expression that can be written within the square bracket with a asterisk symbol. And we can, based on the space, we can increment the count. And with the help of the printf, that value will get displayed. If we will reach it successfully at the end of the program, the yyWrap will return the 1. In the user section, in the code section, we will write the main function, which will return the tokens from the lexical analyzer phase with the help of the yyLex function. So this is the sample program with the help of the LEX. So once this program is written, how we can execute this particular program? So this program is written with the help of the .l file. So if we are using the Windows operating system, then the lexical analyzer that will be used as a Flex. Else you can use the LEX. Once this particular file is being compiled, that can get compiled with the help of the gcc lex.yy.c. And after that, we can execute this particular file with the help of a.exe. So what will happen basically? In the first step, the source code which is written in the C language, which will having the file name here, the hello.l, which will gives the input to the LEX compiler. So commonly known as the LEX to get the output file as a lex.yy.c. So after that, the output file lex.yy.c will be used as an input to the C compiler, which gives the output in the form of a.out file or the a.exe file, which will take the stream of characters and generate the tokens as a output. So with the help of this, we will see how to execute this particular program.